another CCUS.
Yeah.
Pop quiz. What does CCUS stand for?
It's kaleidoscope. No, that's a K. Calories contributing.
Nope.
Under stress.
I guess.
No, carbon capture, utilization, and storage. And we have some great experts here at NOV. We'd already had a show with talking about a little bit of that.
We kind of have a couple.
Yeah, but kind of back to back now we have another one. Kind of the next chain of the usage and storage. Actually, remember the storage part of carbon dioxide.
And what's fun is we're not doing a CCUS series.
Right.
This is truly
just like happened.
How many technologies, how many projects, how much cool stuff is coming out about CCUS right now. So I think it's really cool.
So today we were talking with Anders Vaalandsmyr and from Norway, and I was like, wait, this is really fitting in because our last show we had, we were talking about how we dehydrate CO2, and now we're talking about how do we actually store it and the unique ways that NOV has come up with, or APL specifically, of doing that.
Yeah, and a new project that's kind of groundbreaking, or is groundbreaking.
Yes.
Not kind of. It is groundbreaking.
And it's literally groundbreaking.
It's literally groundbreaking.
Right. Yeah.
Awesome. Let's get into it.
Let's do it.
Yeah.
Okay, Anders. Hi, thanks for having us. Thanks for being with us all the way from Norway, correct?
Yes.
That's great. So, Anders Vaalandsmyr. So, Anders? Yeah, I know. Yeah, it's like
Close
kind of.
pronunciation.
So sorry, but I gave it my best try. Anders, tell us a little bit about what it is you do at NOV.
Hi. Yes. My name is Anders Vaalandsmyr. I'm the Director of Technology and R&D here in APL. And my department is sort of the technology spare front of APL. We are taking care of technology development and also, of course, maintaining our systems and sort of system ownership of the solution that we provide to the industry. This is partly the product development for key products that we need in our systems, and also system developments, sort of new solutions to new problems.
New solutions to new problems.
I like that.
Yeah.
Okay, so we're not talking about old problems, right?
None of that old stuff.
But they are sold a long time ago.
That's right. Well, and I think our topic today kind of almost sounds like a secret spy mission.
Yeah.
Project Greensand. Or Greensand?
Yeah.
So can you tell us a little bit, what is Project Greensand, and why is it important?
Yeah, so we are very happy about being part of the Project Greensand. It's Ineos, our Ineos Energy is our client here, sort of leading this, of course, and we are doing one part of this project, and that is delivering the CO2 injection system for this injection vessel. So Project Greensand is about basically storing CO2, permanent storage of CO2 that it's been captured by others, and they are collecting it, taking out to an existing depleted gas field and storing it for permanent storage. Basically taking some of the CO2 out of the carbon cycle and putting it back basically where it came from.
Okay, so that's going to go right. So you're injecting it into, you said, depleted gas fields, correct? So it's not like subsea storage. It's a different thing. You're injecting it into a well that we previously had taken resources out of.
Yes, so it's basically an gas field, end of life gas field, existing old platform, and it is sort of demonstrating that permanently CO2 injection is possible in an existing with existing facilities. So this is of course also sort of a good idea, not having to build everything from scratch again. You can reuse existing facilities. That means the wellhead platform in this case, and using that for enabling this project in an economical way.
Wow.
And I know APL specifically has been, I want to make sure I get this right, we've been awarded the contract to supply the offshore injection system. So can you talk a little bit about how does that work? How does it successfully store CO2?
Yeah, so the injection vessel, that's the same vessel that goes to the ports in Europe to collect CO2 from the parties that has been capturing, then transporting it to this offshore field. And on this vessel, when it's transported to transport CO2 effectively, you have to compress it and normally cool it down. So they just do both. It's cooled down and compressed. And when it comes to the field, they heat it up. So it's and also increase the pressure, compress it sort of more to keep it liquid.
Okay.
And from that stage, basically, when it's sort of the condition of the CO2 is ready for to be injected into the reservoir, our scope is to enable from the vessel interface to the well interface, basically. So we deliver the riser, basically the pipeline from the wellhead platform to the vessel, the dynamic part from the seabed up to the vessel, and the connector skid that enables you to pick up this riser, connect it in a safe manner with the valves and safety functions for that,
right?
And enables, of course, to disconnect and lay it down again, because this vessel is going to shuttle back and forth, bringing sort of a cargo each time.
Right. So I'm curious about, you had mentioned using existing infrastructure as opposed to building something new. That's a new, is that a new feature that we are able, our NOV's technology is now able to utilize existing infrastructure? What type of things are usually built for this? Are they based on shore? And
there are no usual things.
So this doesn't usually exist.
Basically, no.
Right.
So an alternative would to have a green field, meaning a field there's been no development on, and then you do this. You have to do the work, drill the wells. You have to do the field survey,
right,
and everything. And then you need to have an infrastructure for the subsea, the drilling of the wells and the control of that. But that is sort of taken care of by the existing infrastructure.
Right.
There's no CO2 injection systems on this existing field, but it is a wellhead platform that has sort of the wellhead and subsea infrastructure.
Okay.
Yeah, and that was kind of my question. So we talked about like new solutions for new problems. What about, this is our first, right, correct me if I'm wrong, kind of the first application we've had for this. Can you talk about what makes it such a breakthrough in the industry?
No, so the APL has been around for more than 30 years. So we have been doing loading and production system offshore from the beginning.
Right.
And started in the North Sea with the harsh conditions that we have there, and particularly solving that problem of having a reliable loading system for the worst conditions, mid-ocean conditions, basically. And that has been started with basically loading of oil, which is in many ways an easier product than CO2. It's sort of a liquid in ambient temperature and pressure, and you pump it as a liquid, and it doesn't change phases, basically, so easy. And then we have done a lot of production systems, but that is systems where you have the vessel there, and you are connected to the wells through the vessel, and many of these systems also had sort of gas injection or water injection for reservoir back pressures and boosting the production. But this is a shuttling vessel that is connecting to a well and injecting its cargo on a batch-wise procedure, and that is new, basically.
Yeah.
And there is no vessels that sort of does this for CO2 today, and CO2 is sort of a tricky cargo or a tricky fluid, because it has this phase changes that basically when it's frozen, it's known as dry ice, at least in Norwegian.
Right.
And it is because of when it evaporates from solid in normal atmosphere, it doesn't go to liquid.
Right. Yeah.
It
sublimates. Yeah.
Yes. So it's
a tricky little thing to deal with.
Controlling those phases during the injection stages for the connection and disconnection, that is basically a new problem that we have together with INEOS found a good solution to.
Yeah. I mean, we even had a show recently where we were talking about CO2 dehydration. So it sounds like CO2 in general is very tricky. Like, oh, you have to take all the water out of me, and now you have to compress me, and you got to keep me at a certain stage, pressure and temperature.
Yes.
Yeah. So
picky.
So picky. Yes.
Well, and I have some numbers I also wanted to ask you about. I want to get them right, so that's why I'm going to be looking down. But I know, so the project aims to store 250 million tons. That's why I want to get that number right, because it's significant, of CO2 annually by 2040. So what kind of impact are we looking at? Especially, Europe has a lot of goals for climate, climate targets. Can you talk about what's that impact of that number? Again, 250 million tons of CO2 by 2040.
Annually,
sorry, by 2040.
Yeah.
Mm-hmm. That's a large number for sure.
Right.
And of course, to meet sort of the targets that's set in EU for decarbonization of energy, that is sort of not even enough. That high number, so but it is a really big contribution to it, right?
Sure.
There's several actions that we need to take to meet this, and this is one of the part of the solutions for this, right?
Right.
One of the things to remember is that when we use 1 kilo of fossil fuel, we basically produce 3 kilos of CO2. And that means that if you consider all the vessels, the oil and gas shuttle tankers that goes around in the world, we're basically going to need 3 times as much if you're going to capture and store all in the same rate that we are using.
Right. Right. But
the opportunity there is huge.
Exactly. Yeah. But this seems to me to fit into, again, I mentioned in the last episode, was like, it seems to fit into NOV's, I guess, philosophy of just like, how can we, you would mention, use what we have? Right. How can we cut costs? How can we make things more efficient? And sometimes that's the technology, is like, oh, we're just going to use existing technologies or existing infrastructure, like you had mentioned. Sometimes it's coming up with something completely new that doesn't exist as far as a structure. Sometimes it's using what we have to make things cost less and more available quicker. So I think it's really, really cool.
Right. And and how would you say, like you mentioned, APL, been around the block, has an extensive array of products.
Yeah.
How does this project fit both into, APL's strategy, but also like NOV's broader strategy for energy transition?
No, so these fields that we are for the Greensand field, basically around these fields, APL have delivered loading systems that has been in operation for 20 or 25 years, and of course it's building on that knowledge and that experience that we have. That we know that we delivering a system that will function and do the work for this Greensand project, right? So it is not sort of all new technology for us, but some of it has been qualified for a particular use for this,
right?
Because the parameters of the specification and of course the trickiness of the CO2, as we talked about, is something new. But sort of the marine part of it, handling a riser, connecting, pulling in, that is stuff that we know well of. But for APL, we have been in this business of offshore loading and production for 30 years. And of course, vessel offshore connecting to the seabed, basically, that is what we do. And of course, this market seems to be growing and will be as I see, part of the solution for the future.
Right.
This is something that, of course, we are really interested in being part of.
Well, from the layman's perspective, from the dummy here, it seems to make sense. Like you've been for decades, APL has been like, we're going to get things from down here and bring them up to here. And now, well, we've already got the equipment. We're just going to go from here and put it back down here. And it's not that simple, but to me, that's the simplified version of it. And it makes sense.
It is. Yes, it is. It's in sort of the 2-sentence word.
Right.
It is that.
I love sound bites, so
That's what we do here.
Yeah.
So with CCUS being, like you said, this really exciting space looking forward, is there anything? I mean, this is such an exciting project in itself. Are there any other, any other sneak peeks you can give us for projects coming up or plans looking at the coming years?
We have been talking with several others, operators and vessel owners that is basically looking at something similar, right? So we are hoping that this becomes sort of a larger market, of course, where there are many players that does this. INEOS are taking sort of the first step here in a very good way, showing the way for the others. I think that is it's a salute to them, and we are really happy of being part of that.
Yeah, yeah.
It's very exciting. I appreciate you coming on and sharing a little bit more. And I think the more we can spread the news about, like you said, how exciting and kind of show that example, the better. This is awesome.
That's great. Well, Anders, thanks so much for being on the show with us today. Appreciate you sharing your knowledge. That's really exciting.
Thank you so much.
Yeah.
All right.
Yes.
Take care.
Thank you. Bye-bye.